Okay, today's CSC question is called distinct values subarray. So in this question, we're given an array of n integers, and we're asked to count the number of subarrays, where each element is distinct. The input is first given the first line is just our n, which is the array size, and our second line has n integers, x1 all the way to xn, which contain the array. Print Our output is basically to print the number of subarrays with distinct elements. Okay, so just a clarification, subarrays mean like continuous parts of the array, not just any elements. It's not like you get to pick and choose. It has to be a continuous part. So for instance, here we have four, and then 1, 2, 1, 3. We have 1, 2, 1, 3. Those are the elements of one element. And then we can have 1, 2, 1. It can't have duplicates, so we also have um 1, 3, and 2, 1. These are the possible things. And also 2, 1, 3. Yeah, I'm missing these comp. So the idea for this question is that if we're kind of just like trying to loop through the whole thing and then find each one, we're gonna like definitely time out because if our n is 2 times 10 to the 5, then if we're doing that twice to n squared, then that would be an algorithm that exceeds 10 to the 10, which is bad. Like that's just not doable. So instead, what we're going to do is we're going to keep track of a list of vectors and also a list of set. And we're going to use two pointers inside here, left and the right. And it's just going to keep track of our current valid thing. We're just going to keep tab every time as we move along the thing. And then we're just going to count how many valid things there are. So here we just pretty standard. We have IO stream, vector, set. And then inside our main, we do make the input faster, int in, c in, pretty standard. We initialize our vector to be called R array, which stands for array. We input it for loop so that we initialize the inputs. Next, we set up our set so that we have the thing. And then we set up our pointer on the left to be 0. And then we do want to make our total subarrays long, just in case our answer doesn't exceed it, because we're counting the number of possibilities, which could be maximum n times n plus 1 divided by 2, right? It's like every number no, like basically you can choose multiple. So then that's why it could get much bigger. And the next we just start from the right, moving the pointer along. So we have a for loop from 0 to all the way to n. We're going to see if the thing while window.count of this thing. So we're going to see if it's inside. If there's a duplicate, then we have to move everything and erase from the left pointer and just keep moving the left pointer over. And if it's not the case, then we're just going to insert this into the set of windows. And then we're going to, this is kind of like the major part that keep tab on like the counting, is we're just going to add right minus left plus 1. That's because from this, everything, this set is valid, so its subsets are also valid. So everything from up to that point, including the ending, would just be like sort of like the Haskell function equivalent of like, um, tails, I would say. Like basically just have each part of the thing expanding it out. And that would just be the thing. So then it would just be right minus left plus 1 number of valid things. And in the end, after the for loop, we just output the number of count we have and then return 0. I think the major thing with this problem that was kind of difficult was just the idea of thinking of using both a vector and a set, and then keeping the two pointers as you move along, rather than the brute force method of like just bashing it out because it wouldn't work. Okay, cool. Let's end off here.